start recording. Seems to be recording. Here we go. So we've got network, 3 locations, all connected together via private dedicated lines. We need to set everything up per the requirements document here. The big first thing is we need to get IP addressing going, right? I talked about this last week a little bit. That's just where I prefer to start. I prefer to work in phases, and typically my first phase is let's get end-to-end connectivity for links, for switched networks, those kinds of things. Let me make sure all my subnets are correct. Let me make sure all of my host addressing and router interfaces, and if I need them, SVIs and whatever else IP addressing wise gets done, because everything else is going to essentially live on top of that. In a world such as this one, where we have VLANs, I may also do some VLAN work while I do that, because I have to segment into VLANs to get my proper subnetting going, right? So I'm going to kind of combine VLAN and IP addressing all together across all the sites. I'm going to start up here where there's no VLANs. I just have switches, right? I have plain Jane network. I've got a switch that is assuming defaults VLAN 1. All switch ports are going to be a part of VLAN 1 essentially, meaning this computer or server is going to get an IP address from this subnet. This interface is going to get an IP address from that subnet. You know, in a non-education lab setting, there's probably multiple interfaces up and running, multiple servers or something like that. They would all get IP addresses. It's all from 00. And that's just where I'm going to start. So we have, it might get a little ugly, but let's turn on all our port labels because I couldn't hover for some reason. We have gig 00 on the router side here, and gig 00 on the router side here. So gig 01 is going to be from the 0.0 network /24s, and 00 is going to be from the 1.0. So I'm just going to pop open my command line here. I'm going to do a little bit of housekeeping first. This is HQBR, I believe. We're going to do logging synchronous just because I like that. Probably could do exact timeout, but no big deal. Okay, so we said gig 00 is going to quote unquote live in the 0.0/24 network. In our requirements document, it is said to set all router interfaces, and this meaning LAN interfaces, with the last IP address of the subnet. So I should be able to, let me pull up all the things I want. I should be able to set this gig 00 here as the last IP address of this network. And 1.0/24 means 1.254. And I use a /24 subnet mask, and I'll no shut that and bring it up and running. And while I'm here, we'll get interface gig 01 up and running, IP address 192.168.0.254, last usable IP address of the range, and no shut and get that up and running. While those cycle through their spanning tree, which we'll talk about next semester, I'm going to hop over and set my clients up. My clients should all be, per the document, the first usable. So if this is in the 1.0, it'll be 192.168.1.1, using what it will assume is a default /24, and that's what we're using, so we'll keep it. Here's our default gateway value. If we supply no default gateway, we're not going to be able to get off our subnet, right? That's the default gateway's role, is to get off of our subnet. So if we want this PC to talk to something that is not on our subnet, we need to inform it on how to get to our router. And our router's IP address on this subnet is what? Correct, 254. And I'm also a big fan of taking the extra few seconds to verify that it took, and verify that I can get to that point. ARP, ARP, ARP. Didn't actually fail this time. Went through no problem. So I'll hop up here on the server. Similar concept, but for the 0, right? First IP address that's usable, 0.1/24. And this one is going to use a gateway of 0.254. The router's interface in this subnet. And take a few seconds to verify it took, and to verify that I can get there. There we go. Now, in this situation, I can also, at this point in time, verify that I can get through the router. In theory, that should succeed. All of our base networking should tell us that should succeed, because this PC is going to know where to send unknown traffic, and 0. something will be unknown to it, right? 0 and 1 in the third octet with /24 is involved. More importantly, this one, meaning it's unknown to it. It's to a different subnet. So it will send it up to the router, which we know succeeds. In theory, and we'll go double check while we're talking, this router should be building a routing table, and both of those things, the directly connected routes, should be in it, and there they are. So when this router receives a packet destined for a 0 network, it will send it out the right exit interface. It'll send it the right direction. So it should go back down towards here. The switch will take over the MAC address layer, MAC address level layer, whatever. And then we're going to come back up through in a similar fashion, right? And that's our encapsulation, de-encapsulation process we've seen before. But we can verify all that. So if our server sits at 0.1, ta-da! We can get to our gateway routes it properly, it gets to its destination. Our destination apparently is configured properly to get back to us, in this case back to the router. The router is able to route to us, and we have success. I'm pretty comfortable with, if I would want to, I could probably move on to setting up various things in this area. But I'm just going to, like I said, take it in phases, and I'm going to get the basics like that up and running everywhere, right? So I'm going to treat the center kind of as one big project here. So I'm actually going to go to a new branch. I'm going to move over not in sequential order, but I'm going to move over here to branch 2 then, because of the legacy inter VLAN routing. And per the book and everything, that would be the next topic you would see. Not the next topic, but I don't know if it's the word chronologically, but in the book, it'd be sooner rather than this. So we're going to hop down here. With legacy inter VLAN routing, we're going to have multiple VLANs on this switch here, and each of those VLANs is going to have a switch port going towards the router that will be an access port for that VLAN. So this is, like I said, where I'm going to start rolling some VLAN stuff into it. So I do need some VLANs down here first. Not necessarily first, but that's what I'm going to do. I'm kind of working my way up the stack, right? I want to do layer 3, but there's no use in doing that if layer 2 doesn't work. So I'm going to do the layer 2 stuff, the VLAN. So I'm going to create VLANs 12 and 74. I'm going to associate these switch ports with those as access ports, and because this is legacy inter VLAN routing, I'm going to do a similar thing over here. And then I'm going to hop on the router and give it IP addresses, and my clients will get IP addresses after. And in theory, I should be able to do what I did up here, and I'll be able to test that connectivity. So let's go create the VLANs. Do some housekeeping first. Host name. What is this guy's name? BR2 SW1. So we need VLANs 12 and 74. VLAN 12. Name, we could. VLAN 74. Name, but not required. I don't think it's anywhere in the document where it says to name these, but if you want to, you could. So the VLANs now exist. So I'm going to kind of carve them up the way they need to be. Faster than a 0.1 should be associated with VLAN 12. Faster than a 0.1 should be a access port, and that should be associated with VLAN 12. All right. We're going to do a similar setup over here on 024 for the server to live on 74. You don't have to exit, but I do. Switch port mode access, switch port access VLAN 74. So those are now static access ports associated with the VLANs that they're labeled for. So onto this legacy inter VLAN routing. Again, as we said earlier, we're going to have one switch port per VLAN going to the router, and the router interface that's associated with that VLAN will get an IP address on that VLAN. Now, I have found whenever you're bundling these links like this, it's not always very easy to always go by the labeling. So I'm going to kind of do a little trick here where I'm going to go bring one of these interfaces up first. And I'll explain why here in a second. You may see it. There we go. Hostname BR2 router. Oops. So we were doing one of those interfaces, right? We've got 00 and 01, and we'll no shut that. So 00 on this side is up. That just guarantees, I would probably assume the person who set this up, i.e. me, would have done 00 to 01 and 01 to 02, just kind of that incremental. But this kind of shows me, and the output over here shows me too, that 01's up. So whatever I associate 01 with here, VLAN-wise, I will go put on 00 over here. So I'm actually going to take this in that kind of staged setup, as it were. So int 01 came up, so I'm going to go configure it as a static access port for one of my VLANs. Switch port, oops, we can type, mode access, switch port access, VLAN 12, we'll just take the first one. And so whatever interface of the router is on the other end of this link should be given an IP address associated with this VLAN. And per the instructions in this network, it's going to be the last usable or the first usable, whichever one it is, right? We'll go double check that because I can't even remember. So gig 00 here is the one that we brought up. So this is the one that's going to be associated with VLAN 12. So it's going to be 12.0. But again, I can't remember what do router interfaces get. Last IP address. Router interfaces in our little network get the last IP address. So 12.254. And we'll bring that up. And so while it's doing its thing, I'll bring the client up. So just like I did up there on the HQ. 192.168.12.1. We're using /24 down here, so we'll keep it. And our gateway is, we just set 12.254. So, did it take? It sure did. Can it ping? Maybe. It sure can. So I can get to my router down here on VLAN 12. Questions so far? Then we're just going to go ahead, Grant.
You set VLAN 12 for gigabit 01.
Right. Right. So when and that was just choice, right? These gigabit Ethernet interfaces don't care which one they're on. I just need to have one per VLAN. So I just chose to do 01 as the one that came up when the router interface came up. So it got the first VLAN incrementally at 12. That's just what I chose to do. So in this case, though, we now have to get 74 up and running. So we're going to hop on here and associate 02 as an access port for VLAN 74. And we're going to set the router interface on the other end of that link with an IP address in that VLAN. So in this case, int gig02 is going to be that access, and it's going to be associated with VLAN 74. The router side is going to get an IP address of 74.254. I'm going to no shut it first, just so it starts doing its thing. 74.254 because it's the last usable in that range. That's too many 255s. I was talking. Right? It's been no shut, so it's being brought up. So while it's doing its thing, I'll go to the client on that VLAN, give it the first usable 74.1, again /24, 74.74.254, and can we get there? Ping, ping, ping. Just like in HQ, though, we now should have a pathway for inter-VLAN routing. Well, it wasn't inter-VLAN routing up here, it was just routing, but we are going to inter-VLAN route because we have a VLAN or a client on VLAN 12 that has an IP address that is unique, and it has a default gateway provided to it, which will route it, or not route it, switch it up to the router. The router is going to have built that routing table with the 2 VLANs worth of stuff in it, right? 12 and 74 both exist, and it knows where and which interfaces are associated. So it will be able to route the other end. The destination will hopefully, have all the requisite information to send that back. So can we get to 74.254 and .1? Yes, which I think the server is actually .1. So yes, we can get to both IP addresses. More importantly, we can get to the server's 74.1. Yeah. So we have that inter-VLAN routing through legacy inter-VLAN routing going. Questions on that? Okay. Next area, I need to start setting up some IP addressing and everything. On my left-hand side, on my branch 1, this is a bigger implementation. This is more things to think about, more things to track. This is a router and a stick setup with multiple VLANs, not just 2, it's now 3. And it's a subnetting problem. So we did a subnetting problem together. So in my directions, I went ahead and pasted that in, since we should all have that knowledge. And we're doing VLSM, so we started with the largest number of hosts needed on VLAN 41, and then 32 and 80, and they're going to be 80.0/27, 80.32/28, and 80.48/29 respectively. I've also marked my usable range, so I know that, again, following router interface should be set with last IP address. I know what to do here, right? When I get to the sub interface for this VLAN, it'll use this. When I get to the client for this VLAN, it will be set to this. Same concept for all the others. So we already have part of that done. Now we just need to basically keep it all straight while we work here. So we're gonna go create the VLANs. VLANs gotta exist, right? Now, something we've not talked about, but some of you may have seen, if you just make static access ports for a specific VLAN, it will auto-create those VLANs for you. So that is a valid way of doing that, but I'm just going to go ahead and take the normal approach and create the VLANs first. So make sure I get all my VLAN numbers in my screen here. So I need VLAN 37, 41, and 80. VLAN 37, VLAN 41, and VLAN 80. And then I'm going to associate 01 as a static access port. I'm going to associate that with 37, 02 with 41, and I'm going to tell 024 to be a VLAN 80 switch port. That is done through those physical interfaces. We associate the physical interfaces with the VLANs, right? Faster than 01 is going to be an access port, a static access port. And again, for 37. And faster than 02, switch port mode access, switch port access VLAN, in this case 41, right? I'm doing 02, which runs to the PC1 that lives in VLAN 41. And this is 24, so I'm going to go all the way to 24, and we're going to make it a static access port first, and access VLAN 80. So Mr. Williams and I had a discussion about these commands, and so he was not doing this command, so he was setting it to essentially quote-unquote negotiate this mode, and in this case it would have worked, but if your instructions ever ask for static access ports, then you're probably going to want to run the command switch port mode access first. Well, it doesn't have to come first, but you're going to want to run that command. So if you just do access VLAN 80, what you're doing is saying while an access port be associated with, be living on, be a part of that VLAN. In this case, it would be VLAN 80. And again, these would negotiate most likely because there's no other switch to talk with. There's no other device talking that negotiation protocol. So all my clients should now be quote unquote on the right VLAN, right? So when I get down to my clients for that IP addressing, it should go smoothly. The big thing with the router and a stick setup is, well, it's the stick. It's this, right? Over here we have this legacy inter VLAN routing where each VLAN got a dedicated physical interface, a switch port, going to the router. In this case, we have just gig 01 running up to the router. We're going to need to do two things. One is on the router, and then one is on the switch, right? So we need to set up all of our VLANs to have an associated sub-interface on the router, and we need to have the switch be speaking .1Q and be running as a trunk, right? So you can do either or. I exited out, but since we're already here on switch 1, I'll go ahead and set up switch 1, right? So on gig 01 that runs to the router, I need to be a trunk. We probably should try trunk. Switch port mode trunk. Now, there are other trunk commands we have learned, and if we need them, when we get to them in the instructions, we'll do them. But for basic connectivity right now, all I'm looking at is getting a trunk up and running. So we've got a trunk that by default should allow all the VLANs across, and we have all the VLANs needed. This is branch 1 router. So, in gig 00, I've seen a couple people trying to put IP addresses here, but that's not where IP addresses live on our router and a stick setup. Not for us. So, we just are going to bring it up, no shut it, right? And all of the sub interfaces that we create will just follow suit. I think most of our labs typically have us per the instructions. If you're following the instructions, have us no shut after the fact, and so all of them come up kind of at once. But since I was here talking about no IP addressing, I'm going to go ahead and no shut it here. And again, the sub interfaces should be created with a no shut value set so that they should come up. And this also gets that spanning tree out of the way right now. So to create the sub interfaces, we do the physical interface that they're going to be associated with, they're going to be running on, and then a period, and then some value, and it can be any value you want within the correct parameters, whatever that integer is. But we have been typically trying to set them up to be whatever we're going to associate VLAN-wise, right? So since we have a VLAN 37, we're going to want to create a sub-interface for we're going to create subinterface 37, right? And see where it changes state to up. And as we discussed a couple times now, encapsulation.1q be ran first. Encapsulation.1q needs to be passed a VLAN ID. In this case, we're matching those up with the subinterfaces, so we're just going to associate that with 37. And then you can give it an IP address on that VLAN. Now, we're not using /24s. We're not syncing all the numbers up, so it's not going to be 37 something. This is where I'm going to go back to my subnetting table I created, or my subnetting notes, or whatever I did for my subnetting, and I'm going to ask myself, routers get some kind of IP address from that range, right? And I already forgot. Router interfaces are set with the last in the range, so 37, which my note is wrong here. That should be VLAN 37. VLAN 37 will use 32.32/28. So I'm going to use the last usable, which is going to be 80.46. 80.46. This is not a /24, it's a /28. So I need to make sure I get the subnet mask correct. Anyone have that? 240, 128, 64, 13, and 16. 240, right? Now we're just going to do a very similar setup for the other ones, right? We need a 41 int gig00.41 encapsulation.1q 41 IP address 192.168.80 dot, and 41 is going to pull from my notes here .31/27. 27 is 224. Very good. 31's not going to be right because 31's a broadcast address. So my notes were wrong, but my brain fixed it as soon as I saw that error. So .1, 3233 to 46 sounds right. 48 is 4. Okay, the other numbers I think are all correct. Okay, so no big deal. We see that error. We know we've done something wrong. We double check our math and we find our answer. We cannot do that because that is actually a broadcast address. So when I wrote down my notes, I wrote that down wrong. And so anyone who was going off of my notes also has that wrong. So please be fixing that in your notes. It's probably just a typo, just like this was 32. Just a typo or me not thinking clearly there. So we've got 30/27 here. And now we need to create that VLAN 80 sub interface, gig00 sub 80, encapsulation.1q for VLAN 80, and an IP address for that VLAN at 80.54. But this one being a /29. Anyone have that? 248. It's the same as your /28, but with the added bit value at 8, 240 plus 8, 248. That one did take, so apparently my notes were correct, or that's incorrect in a correct position. You know, one of those. Right? Sometimes you can be wrong, but it's also going to take. We'll see that sometimes, but I'm pretty sure we're comfortable with that one. So all of our VLANs now have a router interface. All of our VLANs now have a way, quote unquote, off of their VLAN. We just need to inform everybody of that information. So when we go to our clients here and give them their first usable IP address, the default gateway value is going to be whatever their VLAN's sub-interface IP address is. Right? Because we're going to want to pass them their router's interface, essentially, in this network. Right, so how's PC0 get address? Well, PC0's and VLAN 37, right? Going back to our notes, which we're pretty sure are correct now. VLAN 37 uses 80.33 as our first usable. 192.168.80.33. We're not keeping that, right? That was a 28, right? So 240. And again, the gateway value is going to be whatever this PC would use to get off the network, right? This PC would use the sub interface associated with its VLAN, and we set on the sub interface of this VLAN 37.46, correct? So we should be able to supply this 192.168.80.46. And we're now going to just take our few seconds, and if you type ping, it should ping 192.168.46. Can I get to my default gateway? I sure can. In theory, once I get other clients up and running and they're properly addressed, we should be able to ping in between. So VLAN 41 on the PC setup. We're going to pull the first usable IP address. Going back to our notes, VLAN 41, first usable is 80.1. 192.168.80.1. And this was a 224 with 80. We end up choosing 30 because 31 was incorrect. Did that take? It sure did. Can I ping? I sure can. So at this stage of the game, while the other VLAN client's not set up, my other one is, and that one was 33, I believe. Right? First usable of that one was 33, and I can get there. So inter VLAN routing for those two VLANs is working. So we'll hop on and we will set 49 on here. Whoops. If we go to the right spot. 192.168.80.49, and this was 248, and this was set to 80.54. Close it out, close it out. It's set. 80.54 is responding. Dot 1 is responding, and 33 is responding. All inter-VLAN routing is working correctly, right? We can route between all of our VLAN's clients here. So all our LANs, at least, you know, the basic networking, as it were, is up and running. And that's going to mark off some of our instructions too, right? I mean, some of our instructions were very, very broad in that make sure this is a router on a stick setup. Well, it is. We're going to mark that off now when we get to that, right? So other basics to get out of the way, though, we have these inter-site links. We have these point-to-point networks, right? We need to get the routers up and running. Eventually, we'll want these LANs to talk with each other. They're going to have to go through these point-to-point links. So we need to get them up and running kind of the same fashion. They need to be able to talk with each other on each end. So this is a matter of mostly just going to the right interfaces and setting up the right IP addresses and subnet masks and everything on them. So it's very repetitive and it should be very quick. So we'll just start on HQ, I guess. And this is where it gets a little funky. It's hard to see which labels are which. So it looks like we're 010 going down here. So int serial 010 should get an IP address from the subnet 255.0/30. Our /30 indicates to us 4 IP addresses, the first and last not being usable, so 0 and 3 not being usable. But 1 is extremely usable because no one has already taken 1. Make sure our /30 mask is indicated. Someone needs a clock rate. Packet Tracer should fill it in for us, but I'm going to set it. It looks like this one took it, so the other end should not need it. I will, no, shut that. And we'll actually end there. I am going to kind of treat this like I did the other ones. We're going to get the basics up and running, so we're going to do this kind of in phases. So we're going to get a link up and running. So I'm going to go to the other side of this link. There's going to be some hopping around here, but I'm going to go to the other side of this link. I believe we're going to want serial, looks like 000. Set up as the other side of this link. So serial 000 should get an IP address from that subnet 255.0/30, but I can't be 0 because that's the network address. I can't be 3 because it's the broadcast address, and I cannot be 1 because that's already used somewhere in this network. I got to be 2. Make sure we get our /30 subnet mask set. I know I don't need clock rate on this side because on our serial interfaces only one is supplied the clock rate. If I were to supply it over here, it's either going to take it and ignore it, or on this platform it'll probably tell us it didn't. Okay, some platforms will tell you you don't need that on this end, and I'm going to no shut that. And if I actually have that up and running, man, don't tell me I actually got that wrong. Then those lights will go green and they should come up, but they totally went down. So 0, 1, 0 and 0, 0, 0, right? So what did I typo? Anyone see my typo? Huh? 0, 1, 0, 2551, no shut. 0, 0, 0, 2552, no shut. Why did that not come up? Yeah, I'm pretty sure I got my labels right. 0, 1, 0. Oops, 0, 1, 0. I was confused why we didn't get the DCE clock rate error. So is this not 0, 0, 0? It's not. It's 0, 1, 0. See how those labels are so screwy? Yeah. So this is actually 0, 1, 0. So I synced those up, those labels. That would make sense that I did that, but totally didn't remember doing that. So we have to fix this error by going on to 0, 0, 0. And taking off the IP address. Yeah, I did get confused why we did not get the clock rate error, or notification probably. So this is actually 0, 1, 0 also. We'll set it up to be 255.2/30. And again, now it probably is going to say only on DCE ends. I was pretty sure something was screwed up as soon as we didn't get that error, but I was going to roll with it and hope it was right. When we no shut that, we should get green lights. There we go, and everything will change state to up. Now green lights don't mean a whole lot. That just means physically it is up and running. But if I can speak with the other end, there we go. Exclamation points indicate success. We're pretty comfortable for moving on. Anything we put on top of this link should probably work, right? At least the layers 1, 2, and 3 are kind of working that we can verify, right? So now that we know our labels are all kind of screwy, but they are synced up, we should be able to hop on 0, 1, 1 and 0, 1, 1 and 0, 0, 0 and 0, 0, 0 and get those up and running. So since we're here, let's do 0, 0, 0 again. 0, 0, 0 is from the 255.8 subnet, but this is also a /30. So I can't use 8 because that's a network address. I can't use 11 because that's the broadcast address. I got to use 9 and 10. I'm going to use 9 here. I've already clock rate and no shut this, so technically don't need them, and we'll just feel confident in that. When we hop over here, oops. When I did that screw up, I already had those things in place. So they're no shut, right? Remember I configured 000 as the other one, so I just took off the IP address, but the clock rate and the no shut are still there, so I don't have to redo them, right? So on this side, int 0000, I'm going to give it 255.10/30, if I get that right. And just no shut it. That should change state to up. Can I ping the 9? There it goes. After it fully came up, we got all success there. So while I'm here on this router, I'm going to get this link up and running, which should be serial 011, which again, don't have to exit. I typically do, but that's just me. This is going to be from the 255.4 network. Now, I'm going to be picky here, and I'm going to say my HQ router gets the first IP address of both of its shared networks. So I'm going to give this .6, right? Because I can't use 4, meaning 5 and 6 are my usable. So I'm going to put 5 on the other end of this. I'm going to give this 6. I don't know which one's the DCE off the top of my head. We can check it, right? But if we just apply it, again, we'll get the error. We can check that with a show interface serial. That's wrong. That felt wrong. Show controller. Show interface controllers. Where is that? Yeah, so just show controllers. Serial 011. And that will be with all my zoom in stuff and my big fonts you can't see, but I can actually see which side needs the clock rates and which don't. DTEs do not get clock rates supplied to them via the command line. They sync up with the other end. The DCEs will be supplied the clock rate by us. So if you ever wanted to do that. So again, that side's now set. So I'm going to hop back onto HQ, and HQ is going to get its 11 set up with .5. It is the DCE because the other end was the DTE. And so when we no shut this, it should come up. We're going to verify 168.255.6, change state to up. So we have success. Questions on that? Two more interfaces exist in this network that I'm going to configure before moving on to other things. It is our connection out to the world, our ISP connection, right? So serial 000 is 15.0/30 and 001 is 15.4. I'm just going to need to essentially set an IP address and no shut that, but I need to make sure I know which one. So over here, you probably should, show IP in brief and all that kind of stuff, but I'll cheat and hover. It looks like this was set to ISP gets first usable of the /30, so I will use the second usable, so I'll use 2 and 6. 2 and 6. So on serial 000, I'm going to do IP address 13.14.15.2 because again, right, serial 000 is 15.0 and it's using .1, so I cannot be .1. And I believe if you double check everything, I set ISP to the clock or to the DCE so it gets the clock. I didn't know why I fully exited that. And serial 001 is going to get, too used to that, 13.14.15 dot, and again, it's .4/30, but this is 5, so I can't be 5, so I will be 6. 3 would be the broadcast address of the first network. And no shut that. And that should slowly come up. I'm going to verify I can get both ends of those links, 14.15.1. is not working. So why? Don't tell me I was not smart. I'm pretty sure I got that right. Fifteen 1, 13, 14, 15, 1, and we set there we go. 13. Oh, I did 15, 16. So again, just kind of gotta know, you know. And this is also another reason why you kind of got to know what to look for. But this is also another reason why I like these phased instances of doing things. Because if I were to have only done this along with one of the instructions said to start static routing, I might be questioning, did I do, while static routing wouldn't impact this decision, this exact ping, I might start questioning what all of the 15 commands I've done in the past 10 minutes is the wrong one. With this one, I knew it had to be one of two things, right? It had to either be the serial interface was set wrong, as in like I went to the wrong one. That's why I kind of moved my labels around. Or it had to be the IP addresses, right? So it looks like I just did the wrong IP address. So we can fix that, right? We can overwrite 13.14.15.2. You got to do the full command, right? There we go. And now we should be able to 14.15.1. There it is, right? Now we got the .6 right, so we should be able to ping 5. There's 5, the other end of our link. So again, you kind of got to know what to be looking for, but because I'm just working on this one little thing, it had to be one of those little things. It's not a bunch of stuff on top of it. You know, if you had chosen to do quote unquote all the things for HQ that their instructions call for, which I know is not much in the grand scheme of things, but if you were to do it all in one go and then finally run that ping across and it failed, you would then have to troubleshoot all of the things that it could be going wrong. By me just setting up the basic layer 3 connectivity, if it did not succeed, I'm only troubleshooting the basic layer 3 connectivity. Now, when I move on to the other stuff, in this case, switch port security, if after implementing it and it does not succeed, what am I troubleshooting? Just port security. Right? I know the underlying network works. So if my port security goes on top of that and breaks it, I know it's just that port security. I verified everything else was working prior to. And that's why I like kind of these little, you know, it might take a little bit longer, but it guarantees me certain phases, certain steps are done correctly, and then I don't have to worry about them as much in future steps. Questions on anything you've seen here? Getting those basics up and running. So going back to our instructions, we've essentially done all of that. 2 LANs completely separate, no customization, so we'll need to come back through and do switch port security. We'll need to come back through and set up SSH. We'll need to come through and we'll need to do the static routes. We did all the underlying stuff for it, but we need to do the static routes, right? We'd set up the redundant links. Various VLANs, make sure each branch has static access ports for the devices as labeled and implement. We did all of this, right? Those are done. You need to set up the WAN connectivity so that each site can speak with each other. So we did the underlying links, but we need to come back through and do the RIP version 2, right? So everything we have done are the highlighted things, and they're the things that we're going to rely on essentially to do these other pieces.